Hello friends, welcome to my channel. In this video, I will cover machine design part 2. Question is, stress concentration factor is defined as, stress concentration factor is sigma maximum divided by sigma nominal or sigma. So from option, ratio of high stress near the discontinuity to endurance limit, no. Ratio of high stress near the discontinuity to yield stress, no. Ratio of high stress near the discontinuity to nominal stress obtained by elementary equation, yes. C is your answer. Stress concentration occurs due to abrupt changes in cross section, correct. Discontinuities in the component, correct. Internal cracks and flaws, this is also correct. Any one of the above. D is your answer. Question is, in static loading, the effect of stress concentration is more serious in case of, its answer is made of brittle metal. Components made of brittle metal in case of static loading. But in case of ductile material, local yielding will occur, so they can resist this one, static loading. So up to certain extent, they can resist this one, but in case of brittle materials, they cannot resist. So this is more serious. And in cyclic loading, the effect of stress concentration is more serious in case of components made of ductile metal. Components for brittle material, yes, more serious for static loading. Both are important. In case of static loading, brittle materials more serious, and in case of cyclic loading, in ductile matter, stress concentration is more serious. The maximum stress concentration factor for a rectangular plate with a transverse hole loaded in tension or compression. One question asked in ISRO scientist also, little bit twist, but answer will be same. Here if you hole is there, so if you apply load in this direction, P, so this direction, this dimension is A, and this side it's B. Stress concentration KT is 1 plus A by B into 2. So here A and B both are same. So 1 plus 2, 3. Answer is 3. Question is, fatigue failure results due to fluctuating stresses when the stress magnitude is more than ultimate tensile strength, no. More than yield strength but lower than ultimate tensile strength. Answer is lower than yield strength. Question is, the criterion of failure for machine parts subjected to fluctuating stress is, its endurance limit. Then next question, the factor of safety for machine parts subjected to reverse stress. Reverse stress means stress versus time graph. If you plot, it will come like this. This value is sigma. This value also sigma. So here in this case, factor of safety. Factor of safety is endurance limit divided by amplitude stress. Sigma A or sigma B also. Sometimes we used to call sigma variable also. Sigma A is sigma maximum minus sigma minimum divided by 2. But in case of reverse stress, sigma minimum is minus sigma. So if you take, this is sigma and minus sigma, it will become sigma plus sigma by 2. So you will get sigma. Once in ISRO scientist also they asked sigma variable stress, GATE also once they asked. So this formula also important. Stress amplitude or variable stress. The endurance limit of a component can be increased or you have to increase the fatigue stress, resistance against fatigue, short pinning. This is your answer. This one also asked in other exams. Cold working increases fatigue strength. A is your answer. Next question. In order to find out the endurance limit, the rotating beam specimen is subjected to repeated stress, reverse stress, fluctuating stress, maximum stress. Its answer is reverse stress. And repeated stress, load will act like this. 0 to P. This is only example. This value 0 to P. This is only for example. And your stress versus time graph, it will become, this is time. X-axis, it's time. Your graph will become like this. Repeated stress 0 to P. This value is P, 0 to P. Here in case of repeated stress, no change in direction, only magnitude changes. But in case of reverse stress, it will come plus or minus P. Your diagram will come sigma, here also sigma, stress versus time graph. Here both magnitude and direction both changes. In case of fluctuating stress, here only magnitude changes. Sigma versus time, but it minimum it won't come to 0. So here let this is P, then this is 2P, it will fluctuate here. Like this it will fluctuate, P to 2P. Your load diagram, it will come like this, P to 2P. No change in direction, only change in magnitude. Sometime in some exam, in question, either they will give the graph or they will give this load diagram or some value they will give. They will ask it belongs to which type of stress. So these three things you have to remember. The notch sensitivity factor Q is given by. This one also asked in IAS, SSC, JEE and other PSU exam also they ask this question. This is very important. Q equal to Kf minus 1 divided by Kt minus 1. Kf and Kt are theoretical and Kt theoretical stress concentration factor and Kf is fatigue stress concentration factor. This is the end of machine design part 2. Thank you friends. Thank you for watching my video. Thank you.